Do you want to monitor the Microsoft Teams call quality data with Splunk? Well, stick around and I'll show you how to do that with Azure Functions. So Microsoft Teams makes a lot of call quality data available, but getting that data can be somewhat of a challenge because there's a lot of pieces involved. Don't worry, because I'm going to show you everything you need to know to get through it. So at a high level, there are three main pieces involved. There is a change notification subscription, a specialized webhook, and a REST client. Now, the change notification subscription, it listens for changes to Microsoft Teams calls in the Microsoft environment, and it sends a notification to a specialized webhook when these changes happen. For example, when a call ends, the webhook is notified about that event. And I say this is a specialized webhook because it has to respond in a certain way with certain return codes, and it has to implement specific validation logic. It also has to be publicly available and HTTPS secured without any private certificates, and it has to be addressable with a URL. And finally, the REST client will periodically read the IDs received by the webhook and make a call to the Microsoft Graph API to retrieve the full call record. It then sends this data to Splunk Indexer. And we're going to use Azure Functions to implement all of these pieces. In Azure Functions, they're just serverless code that runs in your Azure tenant. Now the functions are triggered by some event like a timer or an HTTP post or an item added to a queue, things like that. Then the function code runs to do whatever you want it to do. And finally, the function can output results, and the trigger and the output are typically called bindings in Microsoft terms. Now to get the Microsoft Teams data, we have four main functions. The create subscription function sets up our change notification subscription, and the subscription webhook function implements the specialized webhook. Now when the webhook receives a notification, it drops the notification into a notification queue. And the process notification queue function is triggered when a notification arrives on the queue. Now the function code implements the REST client to retrieve the full call record from the Microsoft Graph API. It then sends this data to Splunk via the HTTP event collector. So this is a push from Azure to Splunk. And finally, the update subscriptions function keeps our change notification subscription up to date because change notification subscriptions can expire if not updated. Okay, let's set all of this up. The first thing we need to do is to create an HTTP event collector listener on our Splunk instance. To do that, we'll navigate to Settings, Data Inputs, HTTP Event Collector, and click New Token. We'll give the token a name and click Next. You can leave the source type as automatic and select the default index for the data and click the Review button. Click the Submit button and then make a note of the token value as we'll need that later. The Azure Functions will need to retrieve the call records from the Microsoft Graph API. So we're going to take a bit of a detour to talk about Microsoft API Graph Authentication. So the Graph API Authentication is done with something called an app registration. And an app registration is a lot like a user account, but instead of a username and password, the app registration has a client ID and a client secret and a tenant ID. And the add-on will use this information to connect to the Microsoft Graph API. To create an app registration, we go into the Azure portal. And from there, we navigate to Microsoft Entra ID and then App Registrations. Now I'll create a new registration and give it a name. And we can leave everything else as default and click the Register button. From here, we can see our application ID and our tenant ID. But now we need to generate a secret. To do that, I'll click on Certificates and Secrets and New Client Secret. You give the secret a name and an expiration time, and then click Add. This brings up the value of the secret. Now this is similar to a password, and it's the only time we'll see it here in the portal. So I'll copy this now and save it to a document for later. Now while we're here, I'll go ahead and assign the necessary permissions to the app registration. So this app registration will handle our change notification subscription, and I'll also use this app registration to retrieve call records. To assign the permissions, I'll go to API permissions, add a permission, and these are Microsoft Graph permissions, so I'll choose Microsoft Graph. The first permission is a delegated permission named subscriptions.read.all. So I'll select that and click the Add Permissions button. The other permission we need is an application level permission named callrecords.read.all. So I'll add that in the same way. At this point, the permissions have been assigned, but they have not yet been granted. If you're logged into the Azure portal as an admin, you can click the Grant Admin Consent button here to finish things up. The next step is to deploy the Azure Functions to your environment. To do this, navigate to the GitHub repository listed below and click the Graph folder. Scroll down the page a bit and click the Deploy to Azure button. This will launch the deployment in your Azure environment. From here, select an existing resource group or create a new one. Give the app a name and note that this has to be a globally unique name. For the Splunk endpoint, enter your Splunk HTTP event collector URL. This is typically the address of your Splunk instance on port 8088, followed by /services/collector. Next, enter the token we created earlier. And finally, enter the client ID and secret from the app registration we created, and click the Next button. A validation will run on the Microsoft side to make sure everything is okay. And if everything goes well there, click the Create button. What is happening at this point is the Azure portal is reading the deployment template from the GitHub repository and deploying all the necessary components to run the Azure Functions. Now that the functions are deployed, we need to create the change notification subscription. To do that, click on the Go to Resource Group button, choose the function app, click the Create Subscription function, and select the Get Function URL button, and then finally copy the URL. Next, we'll paste that URL into a browser, and the subscription details should be displayed in your browser. All right, so we have everything set up, so I'm going to start a Teams call to test this from end to end. I'm going to start the call on this workstation and join it from another browser. Okay, so here is our Teams call record, and there is a lot of data in here. You have information about the organizer, all the participants, and most importantly, the session, which has things like jitter, and packet loss, and frame rates, and round trip time, and all sorts of user experience data. So to make this data more usable, we're going to install the Microsoft 365 app for Splunk, as it has a lot of pre-built dashboards for this data. Now that the app is installed, navigate to Teams, Call Record Monitoring, Teams Call Overview, and this will show you an overview of all the calls that are happening in your environment. And the Teams Call QoS dashboard will give you information about audio and video quality along with individual metrics. And you can even search for specific calls that have happened and drill down into detailed information. And there you have it. We configured the Splunk HTTP event collector to receive data. We set up authentication with an app registration and deployed the functions to our Azure environment. Now you can get started today by visiting the GitHub repository for the functions and splunkbase.com for the Microsoft 365 app. Happy Splunking!